Okay, guys, let's do a little review on gravity here from the Blue Book. Let's move over on page 50. This is Physics 11H. Over on page 50, Newton's universal law of gravitation. Again, this is my version of the book from last year. It's marked up a bit from when I did a review at the end of the year. But you know, the main thing we start with here again is the equation that describes gravitation. We spend a lot of time on this at this point, so, you know, but without seeing you, it's hard to figure out where exactly you are. So tomorrow we're going to have a little quiz. Your homeworks have looked okay. Hopefully you're getting going on that. There's our basic equation, and then we go through this derivation we did before where lowercase g is Fg over m. Talk about Newton per kilogram, meter per second squared, same thing. Gravitational field strength is 9.81. Acceleration due to gravity is negative 9.81. Gravitational field, blah, blah, blah. Always pulls towards the center. Weight is the force of gravity. Okay, gravitational force with which a planet attracts a mass is called weight. Okay, very good, very good. And then it just gets into some problems. So I'm going to just take a few of these right now and go over them with you, and you know, look at putting a couple similar questions on the quiz. I started making the quiz, but it's going to be interesting. It's a little bit hard to do on campus for a physics quiz, but we'll get there. I'm trying to think of the easiest way to do it. Probably mostly multiple choice, but I got to make sure it scrambles up the stuff, and you know, so I'm gonna have to dig for some questions. So let's go ahead with number 104, the very first one there. Which diagram best represents the gravitational forces Fg between a satellite and Earth? And the answer is 3. It's attractive, right? It's always attractive. Pulls towards each other, just like you see there. Classic thing. Number 106, another good one. So 104 was 3. The two objects always just attract. Same magnitude on each. Even this one thing that they'll do sometimes is they'll make one of the vectors bigger than the other. Like the vector on the smaller one being bigger because it's being pulled by a bigger mass. But that's not what it is. When we do Fg equals gm1 m2 over r squared, that is determining the magnitude of the traction on both objects. Anyhow, number 106, the magnitude of gravitational force that object A exerts on object B is 20 newtons. If the mass of each object is doubled, the magnitude of the gravitational force that A exerts on B is, well, this is kind of like what we did on that homework sheet. Fg equals g m1 m2 over the distance between them squared. If A exerts 20 newtons of force on B, that's the initial force. So that's the Fg to start off with, 20 newtons. So if we double each object's mass, so again, we're doubling each mass. You can do it like I did it in the last video, right? Where it's, we don't worry about the g. We just say, okay, it was 1 times 1 over 1. That gave us 20, but now I'm going to double the masses. So it's 2 times 2 over 1. That's going to be 4 times more force now. So doubling each mass, 2 times 2 brings a 4 out in front. The other way you can do it is like I did on the homework solutions, which was g times the new mass is 2m and 2m, 2m1, 2m2 over r squared. So that's 4g m1, m2 over r squared. So it's 4 times bigger. So if it was 20, now it is 80. The answer is 4 for number 106. So, number 110 is a trick. All right, it's a trick. It says, which of the graphs best represents the relationship between the mass of an object and its distance from the center of the Earth? This is like that inertia question. If you have something, its mass is, let's say, 80 grams or something, if you move it some farther distance from the center of the Earth, its mass doesn't change. The mass stays constant. So the graph that shows a constant mass versus distance, so the distance gets bigger, the masses stay constant, it's a flat line. So it's 4. So that's a bit of a trick question. The one that usually gets asked is, which of the following graphs shows a relationship between the force of gravity and the distance between two objects, or the distance a satellite is moved from the center of the Earth? And that is that inverse square relationship, right? When it's force of gravity versus distance. So watch out for that. Number 113, which graph best represents the relationship between acceleration due to gravity for objects near the surface of the Earth and the mass? This is another one. The acceleration of due to gravity, g, near surface of the Earth. If you're near the surface of the Earth, g is just 9.8 meters per second squared. It doesn't change. It doesn't depend on mass. So the acceleration versus mass is just constant. So that's that one's a little bit strange. Anyhow, the solutions for this chapter are posted right in the front page of the classroom over on the right side there, Blue Book Solutions. That's really pretty much about it there. The questions are pretty straightforward. I would go back and look at the solutions for the worksheet. That'll 2.2.2. Watch those videos on it. That should help you out. Again, the big things are, okay, if you change the masses and you change the radius, how does that change the overall force? Plugging and chugging in your calculator to determine the force of attraction. That's pretty easy. If you know the constant big G that's in the front of your reference table, the mass of each object. And again, R, remember, is the distance between their centers. Okay? All right. So I think that's about it. No other really great questions right there. There are some in the back here, the review questions. Those might be worth checking out, some of those, and then the practice questions for the Regents exams. Try to figure out which ones have to do with gravity. Maybe take a look at those. All right, have a good night. We'll talk to you later.